Next we're talking about a fact family. When my son came home from he is in the second grade. When he was in the first grade, they came home with a lot of fact families, and he does it a little bit now. But example of a fact family for this one, 5 plus 9 equals 14, is you're going to have 4 groups. So 5 plus 9 is 14, but also, using our commutative property, 9 plus 5 would also equal 14. Okay, so those would go together. Then you can flip it around and make them subtraction. 14 minus 9 would equal 5, but also 14 minus 5 would equal 9. And that's an example of a fact family. Now, parentheses placement. What you'll notice about these next 2 problems is that they are both exactly the same. But one answer is going to have an answer of 7, and one answer is going to have an answer of 11 just by putting the parentheses in there. So the way that you would work it is, or the way that I work it, is I just put the parentheses in there and I try it. So let's say I put the parentheses in right here. This gives me 14 minus 5 minus 2. Okay, so 14 minus 5 would be 9, and 9 minus 2 would be 7. So this answer right here would be 7 if I put them right here. So I got it on the first try. That doesn't normally happen. So let's try the second one. Okay, so I know it's not going to be this one because we just tried that one. So let's try it here. This would be 6 plus 3 minus 2. Okay, so 6 plus 3 is 9, and 9 minus 2 would give me 7. Oh, I could have used that one for the top one. So there would be more than one answer to that top one. Okay, but that doesn't answer my question because I'm trying to get 11. Okay, so let's try to put it around these 2. This is 6 plus 8 minus 3. So this is 14 minus 3, which would be 11. Okay, so that's where I would put them there. As far as this, I know there's some like this in your quiz and in your My Math Lab homework, but as far as this one goes, I just try it out until I find the group that works. It's just like a process of elimination type. Okay, and then we move to multiplication. So we'll do the same thing with the multiplication that we did with the addition. Okay, so 5 in multiplication, 5 would be called a factor, and 4 is also called a factor. And when you multiply 2 things together, what you get back is called the product. Okay, so that's how that would go. Now, as far as the different types, you've got these different types. The first is repeated addition. So if I was thinking of 4 times 5, that means I'm going to take 5 4s or 4 5s. In this case, 1, 2, 3, 4, 5. I took 5 of those. So repeated addition means I'm going to add 4 to itself 5 times. 1, 2, 3, 4, 5. So 4 plus 4 would be 8. 8 plus 4 would be 12. 12 plus 4 would be 16. And 16 plus 4 would be 20. So for the student that says, I just don't see it, I just don't get how you did that, one of the ways that you could show your students is say, just tell them, okay, so let's take 5 of these. 1, 2, 3, 4, 5, and let's add them together. And if I add together 5 of those numbers, I'm going to get 20, which is the way that you would get it if you said 4 times 5. The next way that we'll talk about is the array, and the array is really good in the elementary school system, and because they can see it. And so especially if you can get some graph paper, you can even print graph paper online and give it to your students with a highlighter. So if you see this one, I have 1, 2, 3, 4 of these. So I have 4 things going down. And 1, 2, 3, 4, 5 of these. So I have 5 going across. And you'll see what that makes is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So it makes 20 boxes, and they can count the number of boxes, and then they can just take a big piece of graph paper and do it how they wanted. So if you were saying, let's see if we were going to do 3 times 4. So I need to color 3 lines this way, color 4 lines this way. So I have 1, 2, 3 lines going this way, 1, 2, 3, 4 lines going this way, and if I color all of that in, I'm going to get 12 boxes. So that's a way that you can show them. Skip count. Okay, so teach them to count in groups. 2s and 5s are really easy to do this way. So if I was counting by 4, I'd say 4 is not quite as easy, but 4, 8, 12, 16, 20, 24. So 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, and 4 times 6. Okay, and here's an example that you have here, and unfortunately that's not a live link because I have a PDF here, but I'll put this link on the page in Canvas so you can click on it and watch a video of it. Okay, we already did this part, so let me take this out. Okay, you do have different properties in multiplication, just like you did in addition. Closed under multiplication is the same thing we talked about earlier. If you took a whole number 3 and you multiplied it times a whole number 2, what you're going to get back is a whole number, and that's what closed under multiplication means. Identity, remember, means you get back yourself. So if I said the number 3, and I'm going to say, what can I multiply by the number 3 to get back itself? That value would be 1. So 1 is called a multiplicative identity because when I multiply a number by 1, I get that number back. So that's an example of a multiplicative identity. Okay, the associative property, that's when you have more than one. So let's say I had 4 times 3 times 2. If I multiply these two first, that's 12. And 12 times 2 is 24. I'm going to get the same thing as if I multiplied these two first. So this is 4, and this is 6. And 4 times 6 is 24. So the associative property says if you have 3 terms, it doesn't matter the order in which you work them, you are going to get the same answer if you group the first 2 as if you grouped the second 2. Okay, the one I left out here was commutative. Remember, if you have 3 times 2 and you reverse the order 2 times 3, you're both going to get 6 regardless of the ordering. So that's your commutative property for multiplication, just like you had it for addition. And the one that is new is distributive. And so distributed says if you have a number out in front of parentheses, that means you're going to multiply this 9 through by both terms. So you would have 9 times x and 9 times 3. Don't let me mess you up with that x. We'll get to x's later. But that would be 9 times x plus 27. And that would be your distributive property. Okay, and I'm going to stop there with that video.